Good evening friends, this is Professor Vishal and in today's lecture we are going to study mathematics for 10th standard SSC board and we are discussing about the chapter circle. Okay, now we have started this chapter and we are almost at the end. Now we are going to solve the practice sets. That is practice set number 3. So it will gives you complete idea. It will consist of various types of problems and we are going to solve at least 4 problems in a session. Okay, I will try to give you solution of these 4 problems in a complete manner. Okay, now let us start. We will discuss this problem number 1 is of objective type. You can easily solve it. I am going to start with problem number 2. Okay, now in problem number 2, question is like this: line L touches the circle with center O at point P. If radius of the circle is 9 centimeter, answer the following questions. Okay, so this data is given and some questions are given. First question given is what is the distance of OP and why? Okay, the second question asked is distance of OQ is given as 8 centimeter and where does the point Q lies? Okay, and there is a correction in third question in your book. Actually it is distance of O to R. Okay, you have to correct it. This question is I'm correctly reading it. Distance of Q to R is 15 centimeter. How many locations of point R lies on line N? Okay, so here there should be lies. Okay, and what is the distance will each of them be from point P? Okay, so this is the question. Now we will discuss. So diagram is given and draw this diagram here. So circle is given like this and let us say this is center O and this is point P. Okay, and this one is the tangent. This is your line L. Okay, now if we see in this question, first question is there, they will ask you, or basic data is given, radius of the circle is given as 9 centimeter. Okay, now if this radius is given as 9 centimeter, we have first question is what is the distance of D to OP or distance of O to P, we can say. They will ask what is the distance of this point P from O. Okay, now as we all know that this O to P is, or we can say OP is a radius of circle and radius is given as 9 centimeter. So I can write this distance of O, distance of point P from O is itself 9 centimeter, isn't it? Why? We can provide this reason because it is the radius. So this is the most simple question, sub question I can say. So in this question they will ask interested to know what is the distance of point P from O. As it is the radius, OP is nothing but the radius. So which is given and radius is given as 9 centimeter. So I can say distance of P from point O is a 9 centimeter. And why? The reason is that this is the radius. Okay. Now we will move towards our next question. So in second question what they will ask us, if the distance of OQ is 8 centimeter, means what? Here we have to mark the point Q which is not given in your figure. Okay, so they will just give us distance of O to Q is 8 centimeter. Where does the point Q lies? Okay, now see, so this is the solution of your first sub question, we can say. Now we will solve here second sub question. Okay, as we all know, radius is given as 9 centimeter, isn't it? That is OP. So this distance is given as 9 centimeter, we can say, and distance of OQ is given as 8 centimeter. Now one thing is clear, this distance, or we can say OQ is less than the radius, isn't it? If the point Q is located at a distance less than the radius, so it means what? It is located in the inside portion of the circle. So we can easily write down here, answer of this question is that as the distance of O to Q is less than radius, so that Q point lies in the interior of the circle. I can write here Q point lies in the interior of circle. Okay, this is the answer of your second sub question. Okay, now we will solve 2 questions out of 3. Now we will move towards our third sub question, so for which I am going to rub this portion. Okay, now third question is there. They will ask us, if distance of O to R is a 15 centimeter, this distance is given from O to point R is a 15 centimeter, how many locations of point R lies on the line L, and what will be the distance from that point R from point O. Okay, here if we say, let us see, and it is mentioned that point R lies on the line L. Okay, so let us say I am taking R point at this location. For example, I have to assume here, and I will join this line. Okay, now as we all know, according to the tangent theorem, if this L is the tangent and intersects at the circle, so here we can say it will create 90-degree angle with radius. This is what the tangent theorem is. So according to that, I can write this OP is perpendicular to line L, and therefore I can write this angle OPR is a 90-degree in triangle OPR, isn't it? Now if this angle P is a 90-degree because of this tangent theorem, I can use here Pythagoras theorem, isn't it? See, this according to Pythagoras theorem, I can write OR square equal to, so this is what your hypotenuse, because this is 90-degree angle, isn't it? So hypotenuse square equal to square addition of square of other two sides, that is OP square plus PR square. Now here this distance is given out of these three. This OR is given as 15 centimeter. Okay, so I will put this value 15 square equal to OP is nothing but the radius, and radius is given as a 9 square. So radius is given as 9 centimeter. So 9 square plus PR square. Okay, now if I will simplify it, what I will get, therefore PR square equal to 15 square minus 9 square. Okay, now as we all know, square of 15 is 225 and 9 square is a 81, isn't it? If I will subtract it, I will get this PR square as a 144. Okay, therefore taking square root, I can write this PR as a root of 144. Therefore that is the value of PR is, and square root of 144 is a 12. So I can write this PR as a 12 centimeter. Now what is this? This is if this distance is 12 centimeter, we can say that distance of this point P to R is a 12 centimeter, or we can say this distance is a 12 centimeter. Okay, now our question is that how many locations point PR lies on the line. Okay, I am assuming initially I assume that this point is at this location, either this, or I can assume that this point R will lies on the opposite side or left hand side of the point P. Okay, but the distance is what? So simply I can say that the distance of this point R from point P is a 12 centimeter. Okay, and it will lies at 2 locations on this line L. Okay, this is what the answer of your first question. Okay, I hope you will understand it. Again I will repeat this particular portion. So I am considering this angle as 90 degree according to the tangent theorem, because tangent touches the circle, it will produce 90 degree with the radius. Okay, so according to that, this triangle is a right angle triangle. Then I will use Pythagoras theorem here, and I will calculate the value of PR. Okay, and I will get it as a 12 centimeter. So I can say that this point R located from point P is at a 12 centimeter, and it will lies either on this location, at this location, or at this location. So distance is 12 centimeter. Okay. Now we will proceed for our next question, that is question number 3. We are going to start question number 3. So in question number 3, it is given that a diagram is given, circle is there, whose center is M. Okay, I will read the question again. In figure, M is the center of the circle and segment KL is the tangent. Segment KL is the tangent segment. If MK is 12 unit, KL is 6 into root 3 unit, we have to find out two parameters here. First one, we have to find out radius of the circle, then we have to find out the measurement of angle K as well as angle M. Okay, so firstly I will draw here a diagram. So circle is there with center M, and this is your point L, and I can directly draw here. This is your point K. Okay, and here in this diagram, MK is given as 12 unit, okay, and KL is given as 6 root 3. We have to find out two parameters here. Firstly, we have to find out the radius of the circle, and secondly we have to find out the angle K and angle M. Okay, now if we see here, it is clearly given that KL is the tangent segment. This KL is the tangent segment. Okay, then I can write here, if this KL is the tangent and it will touches the circle at point L, so according to the tangent segment theorem, it will create 90-degree angle with a radius, isn't it? So radius in this circle is the ML. So I can say that this angle is a 90 degree. Okay, according to the tangent segment theorem. So I can write here, according to tangent segment theorem, this angle MLK is a 90 degree, isn't it? If this is a 90 degree, we can say that triangle MLK is a right angle triangle, isn't it? And if this is a right angle triangle, I can use Pythagoras theorem here. So I will write here, according to Pythagoras theorem, isn't it? So this, if this is 90 degree, this is your hypotenuse. So I can write hypotenuse square, that is MK square, equal to ML square plus KL square, isn't it? And I am going to put this value here at this section. MK square, MK is given as 12, so 12 square, which is equal to ML is radius, which I have to find out, and KL is given as 6 root 3. So I can write here in bracket 6 root 3 whole square, isn't it? Then I can write this ML square equal to, I will rearrange this, 12 square minus, see, 6 root 3 whole square means what? 6 square and root 3 square. 6 square is a 36 and root 3 square is a 3 simply. Okay, so I can, so after simplification, 12 square is 144 minus 36 into 3, 3 6 is 18, 1 is remaining, 3 3 9, so it becomes 108. Okay, so I can write it somewhat clear. So this becomes 144 minus 108. Okay, so if I will subtract it, I will get ML square as a 36. So I can write ML directly. Square root of 36 is 6. So 6 unit is the radius of this circle, isn't it? So simply, firstly I have to use tangent segment theorem, and accordingly that I am going to prove this, then I can write this angle as L, and if this angle L is 90 degree, so I can say that this triangle MLK is a right angle triangle, and accordingly I will use Pythagoras theorem here. ml mk square equal to ml square plus kl square. All these values are given. After simplification I will get ml as a 6 unit. Okay, now we will proceed for our second part. So that is angle k and angle m. How to calculate these two angles? Okay, I hope it will clear to you. You can take this snapshot of this screen, then I will proceed. Okay. So I can write here, if mk is a 12, kl is a 6 root 3, and ml what I will get as a 6 unit. Okay. Then I have to find out the angle k and angle l. Okay. So it means I have to find out these two angles. Okay. So this distance is a 6 root 3, this distance is a 12, and this distance is a 6. Okay. Now see, if you remember the 30, 60, 90 degree angle theorem, according to that theorem, if this is the hypotenuse, okay, and this hypotenuse, and this is the opposite side of angle k, let us say, okay, if this side is half of the hypotenuse, so I can say that this angle is a 30 degree, isn't it? Or let us say if this is root 3 by 2, this angle is a 60 degree. Similarly, so I will take the ratio of respective respective sides, and I will get the angles. I will going to use the converse theorem of 30, 60, 90. Okay, so I will start with this. Firstly, I will take the ratio of ml upon mk. Okay, ml I calculated as a 6 unit, mk is a 12. Okay, so 6 1s are 6, 6 2s are 12. So I can write here ml equal to ml upon mk equal to 1 by 2, isn't it? Therefore I can write ml equal to 1 by 2 of mk, isn't it? Means what? This, whatever the distance of this side is half of this hypotenuse. This mk is hypotenuse in this triangle, isn't it? Because this triangle mnk is a right angle triangle, angle l is a 90 degree, so this is hypotenuse, and this side is half of the hypotenuse. If this side is half of the hypotenuse, means what? Angle in front of this side is what? 30 degree, according to the converse of 30, 60, 90 degree theorem. Therefore I can write here, according to converse of 30, 60, 90 theorem, angle k is 30 degree, and this is what you have to calculate. Okay, now in order to calculate angle m, what I will do, I will take the another ratio, that is I will use this kl divided by mk. Okay, now here if you see, kl is 6 root 3 and mk is 12, isn't it? So both values are given. Again I will write it correctly, so it becomes 12 unit. Okay, so if I will simplify it, I will get 6 1s are so 6 2s are 12. So I can write this as a kl equal to root 3 by 2 times mk, isn't it? Now again this mk is hypotenuse and kl is the side. Okay, now this kl, if this side is root 3 by 2 times of the hypotenuse, so if this side is root 3 by 2 times hypotenuse, means what? Angle opposite to this side, means that is angle m, is 60 degree. Again I am going to use the converse of 30, 60, 90 degree theorem. Therefore I can write angle m is 60 degree. Okay, and reason is what? You have to put the same reason, a converse of 30, 60, 90 degree theorem. I will here write it shortly, 30, 60, 90 degree converse of. Okay, so in this way you will get these two angles as well as radius. So this is a very simple question. Firstly we calculate the radius, it is found to be 6 unit. Then we calculate these two angles, angle k and angle m. Okay, for which you have to use the converse of 30, 60, 90 degree theorem. In first step, what I will did, I just take the ratio of this side to the hypotenuse. I will found it to be 1 by 2. So we can write ml is half of this mk, means this side is half of the hypotenuse, and this side is half of the hypotenuse, means what? Angle opposite to this side is a 30 degree. isn't it? Similarly, I will use this second ratio KL by MK, and it is found to be root 3 by 2, and if it is root 3 by 2 means this side is root 3 by 2 times. Okay, in this way you can calculate these two angles, angle M and angle K. Angle K is a 30 degree, angle M is a 60 degree. Okay, now we will proceed for our next question, that is question number 4. These questions are again based on previous concepts from this chapter. Okay, now we will discuss about question number 4. So in this question, a diagram is given and O is the center of the circle. Segment AB and segment AC are tangent segments. Two tangent segments are given. The radius of the circle is given as R and length of AB is given equal to R. Again, radius and length of AB are same. We have to prove that quadrilateral ABOC is a square. Okay, now I am going to draw diagram here. Circle is given, and here let us say circle with center O is given, and this is point A. Okay, okay, this point is point A. I will correct it once. Circle with given, where two tangents are given there. This is center O, this point A, this has a B and this has a C. Okay, here they will given radius of the circle as a small r here, and length of AB is given as R. Okay, now here I have to do some basic construction here. I am going to construct, that is I am going to join O to B and O to C. Okay, I am going to join these by dotted lines. This is O to B and O to C. Okay, now if we see, we have to prove that this quadrilateral ABOC is a square. Okay, so this quadrilateral is a square. We require two conditions. Okay, most of the times what will happen, we think that if four sides of quadrilateral are equal, it is square. No, it may be a rhombus, isn't it? So in order to prove if it is in order to prove this quadrilateral as a square, we have to find out we have to show that four sides are also equal, as well as four angles are also 90 degree angles. Okay, now we will see, first we will prove that the four sides are equal, then we will see how these angles are equal. Okay, now if we see in this problem, this particular AB is given as R, isn't it? This basically this quadrilateral ABOC, length of AB is given as R. Okay, if you see here, the point of generation of these two tangents are same, and if the two tangent segments are generated from same point, they are congruent, isn't it? So accordingly I can write AB is congruent with AC, or we can simply write length of AB is congruent with length of AC, and which is given as R, isn't it? So if AB is R and AB and AC are equal, then AC is also R, isn't it? Means what? This AB and this AC is equal to R, and as we all know, see if I will join this line OB and OC, these are what? OB is also and OC, they are called as radii of the circle, which is equal to R, isn't it? So from let us say I am putting this as equation 1 and putting this as equation 2. Okay, if this AB and AC are equal, they are equal to radius. Similarly, OB and OC are also radii of the circle. Then I can say that easily, I will write it here. this particular AB equal to AC equal to OB equal to OC, which is equal to radius, and as these sides are equal, first part of our proof, what we have to prove, that quadrilateral ABOC is a square, is completed. Okay, so I will put this as a equation number, respective equation number 3. Okay, I have to use this equation in order to finally prove this particular statement that this ABOC is a square. Okay, now my intention, once I will get these sides are equal, I have to prove that these all angles are equal. Angle A, angle B, angle C and angle B not equal, they are 90 degree. Okay, there and then only I can say that this quadrilateral ABOC is a square. Okay, now I will rub this. If you want, if you can take snapshot of this, I will quickly revise it again. So this distance is given as R, isn't it? It is given in your problem. And why I am writing this AB equal to AC, because these tangent segments are generated from the same point, hence I can write AB equal to AC, and which is equal to R, and I will join this OB and OC, they are nothing but the radius of the radii of the circle. So according to these equation 1 and 2, I can write AB, AC, OB and OC are equal. Okay, so then putting this is the equation number 3. Okay, this is your equation number 3. Now what I will do, I have to prove that these 4 angles are 90 degree angles, then and then only I can say that given quadrilateral is a square. Okay, now if we see, this OB is perpendicular to AB. Why? Because again tangent segment theorem is there, isn't it? Means what, this segment or this tangent touches the circle at point B, so it will create 90 degree at this point, isn't it? So I can say that this OB is a perpendicular to AB, therefore angle B is what, or angle ABO is a 90 degree angle, isn't it? Similarly, if this is a 90 degree angle, this triangle ABO, I am going to consider in this triangle ABO, if this angle is a 90 degree, and again I will write ABO is a 90 degree, and this side AB is congruent with side OB, because both are radii of the same circle, or whose value which is equal to R, so I can say that they are congruent, isn't it? So I will put nothing here, just have to mention here which is equal to radius of the circle, isn't it? So now if this angle is 90 degree and these sides are equal, this triangle ABO is isosceles triangle, isn't it? And accordingly, if I will add these 3 angles, it should be 180 degree. So I can write this angle ABO plus angle BAO plus angle AOB, which is equal to 180 degree. Okay, now this angle is a 90. If I will assume this angle as a x and this is also x, okay, I will put the value ABO is a 90 degree, BAO is x and ABO is x, which is equal to 180. So I can write here 2x equal to 180 minus 90, or I can say that 2x equal to 90, therefore this x is 45 degree, isn't it? If this x is 45 degree means what? This angle BAO equal to angle AOB equal to 45 degree, isn't it? Means these two angles